5-2 is perpendicular and angle bisectors. We know what both those things are, right? What's a perpendicular bisector?
It's 90 degrees and it is
90 degrees and it's a midpoint, right? Perpendicular bisector is something that cuts something in half at a 90-degree angle, okay? What's an angle bisector?
It bisects the angle in one place.
Cuts the angle in half, right? So we're going to talk about perpendicular bisectors and angle bisectors in this lesson. So here's what I want you to see, okay? This is a perpendicular bisector, right?
There's D on it.
To segment,
It says AD.
oh, let's call this D. I think I changed my letters. Sorry, that should be a D. Not a P. Okay, so if this is our setup, we can say right now that triangle ADC is congruent to triangle BDC. Why?
Angle bisector. Definition of a
Side, angle, side, right? This is reflexive. So the triangles are congruent by SAS, which means since those triangles are congruent, then AC will be congruent to BC. Why? No. CPCTC.
You know this stuff.
Okay? Because we just did it in chapter 4. This is just chapter 4. So here's the thing. We're using chapter 4 information to prove to us that this distance and this distance will be the same when you have a perpendicular bisector, okay? It is called the perpendicular bisector theorem. Here's what it says. If a point is on the perpendicular bisector of a segment, then it is equidistant. What does equidistant mean? Equal distance, right? Then it's the same distance away from the endpoint. So that's what they're saying here. Here's an endpoint A, here's an endpoint B. If a point, point C, is on the perpendicular bisector, it must be the same distance to A as it is to B, which means I could pick a point way down here on the perpendicular bisector, and what's going to happen is the distance to A must be the same as the distance to B. Okay, so if it falls on the perpendicular bisector, it will be the same distance away every single time. Yes, ma'am.
Do we have to prove it by SAS or could we?
No, this is just me proving it to you. You won't have to do any more SAS, SSS, any of that. I just want you to see why it has to be perpendicular and then equidistant. Okay, so that's the first theorem. The converse, what does the converse do?
Opposite.
Just flips it, right? So if a point is equidistant, can you see that? Sorry, I meant to change from yellow and I didn't. Then it is on the perpendicular bisector. So you're just swapping from the first one, okay? So if it's perpendicular, then it's going to be equidistant, or if it's on the perpendicular bisector, it's equidistant. If it's equidistant, then it is on the perpendicular bisector, okay? All right, so here's the deal. Let's look at this picture. Notice you have, what? You have a perpendicular bisector, right? So EG is a perpendicular bisector. That means every point on EG is the same distance to D as it is to F. So in this picture, how would you solve for X?
Set X plus.
X plus 6 equal to 2X. Do you want to know a little hint? You're going to set a whole lot of things equal today. This is equal to that because E is on the perpendicular bisector. So we can say X plus 6 equals 2X. So take away the X and X equals 6. So then what is EF? 12. Plug the 6 in. 2 times 6 is 12. Okay, look at letter B. You have a perpendicular bisector, right? So UT is the perpendicular bisector of RS. That means any point on UT is the same distance to R as it is to S. what do? Set them equal. Take those two. 10x minus 3 has to equal 5x plus 2. So take away the 5x and add the 3 and divide by 5. Okay, so x is 1. What is RT?
7.
10 times 1 is 10, minus 3 is 7. Okay, that's the perpendicular bisector theorem. So if you see a little box, a perpendicular, with two segments congruent, pretty much you're setting the parts equal to each other. Okay, perpendicular bisector theorem. The second and final theorem is the angle bisector theorem. And this one says, I totally changed that. The angle bisector theorem says this: if a point is on the bisector of an angle now, then the point is equidistant from the sides of the angle. Okay, the converse of that is also true. If a point is equidistant from the sides of the angle, then it is on the angle bisector. So look at this picture. Here's what this means. If I have an angle BAC, okay, two ways you can look at this. The first way, the original theorem, the angle bisector theorem, says if I bisect this angle, so if I know those two angles are congruent, then the distance to them is the same. And now here's the tricky thing about the angle bisector. The distance from point D to our angle must be perpendicular. Because I could say, oh yeah, I'm this far away, or I'm that far away. That's not how we do it, okay? We always use the perpendicular to tell distance. So this is the distance that we're gonna use, and this distance will be the same then. So these two segments would be congruent. Okay, that's the angle bisector theorem. The converse to the angle bisector theorem would be, I'm going to take all that away now. The converse would be if I have a line right here, but they don't tell me that the angles are equal. They just say, here's a perpendicular, and they're congruent. Then I know AD is an angle bisector. Okay, so you can look at it either way. Let me show you what you're going to do with these. Again, a whole lot of setting things equal, you guys. A whole lot of setting things equal. Look at this. They're asking you to find BD. These angles are congruent, meaning this is an angle bisector. Okay, and if it's on an angle bisector, like point D is on an angle bisector, then the distance to the angle is going to be the same in both directions. What do? Set them equal. 3x plus 1 has to be the same distance away as 5x minus 1. Okay, so you set them equal and you solve. Take away the 3x. Add the 1, so you get 2x equals 2, divide by 2, so x is 1, okay, but they didn't ask for x, they asked for BD. BD would be 4, so you're going to plug it in, 3 times 1 plus 1, so BD is 4. Does that make sense? When in doubt, set it equal. Okay, look at this one. They want to know what the length of DC is. It's 5, right? If they tell you these angles are congruent, then this is an angle bisector. And if you have an angle bisector, the distance to the angle is the same. So if this one is 5, then DC also is 5. That's not bad, right? It's very doable. Okay, look at this one. Look at your markings. They want angle CAB. So CAB is this angle. It's 40. Because these distances are the same when perpendicular, then this angle is being bisected. So that means this one is 20 also. So CAB is 20 plus 20, or 40 degrees. Good on that? Okay, last one. Look at your markings here. We want to find X. What do? Set them equal. If the distance to the angles is the same, so because that's 5 and 5, then this is an angle, God bless you, this is an angle bisector, which means those have to be congruent, which means 4x has to equal 2x plus 20. So take away the 2x, and you get 2x equals 20, so x is 10. So how big are those angles? 40. They're both 40, right? Because they're equal. 40 and 40. Questions on that? What are we listening to? I don't want to hear your music.
Yeah, I know.
So why am I?
You are?
Oh, yeah. Quite loudly. Yeah. Okay, that's all we got.